Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 9th, 2025, about 3 days ago. This paper highlights a critical challenge, that even our best video generation models struggle to create consistent clips longer than 16 seconds. The paper is titled, A Survey on Long Video Storytelling Generation, Architectures, Consistency, and Cinematic Quality, and it lays out a really clear roadmap for how researchers are tackling this. It comprehensively reviews 32 different methods to identify the best architectural components for making longer, more coherent videos. Alright, so to organize their findings, the authors created this really helpful architectural taxonomy. It's essentially a family tree that sorts the 32 different methods into 6 main branches based on their core design. For example, you have approaches like keyframes to video, which generates important still images first and then fills in the motion. Then there are others like discrete temporal chunks, which break the video into smaller, separate blocks to make the process more manageable. This structure really helps to clarify the different trade-offs each approach makes. Building on that taxonomy, this table gives us a much more detailed look. It's a comprehensive backbone table comparing different frameworks organized by their training objective, which is the specific mathematical goal the model aims for during learning. It breaks down the key components for each model, like its backbone, which is its core processing engine. We see a clear trend towards using more sophisticated parts, like a 3D variational autoencoder. A variational autoencoder is a module that's really good at learning the essence of visual data, and the 3D version is tailored specifically for video's space and time dimensions. This next part of the table continues that breakdown, showing more models and their components. We see columns like positional encodings, which is how a model keeps track of the order of frames, so it knows what comes before and after. Some use advanced methods like 3D rotary positional embeddings to handle video's time dimension. The table also lists the number of parameters, essentially telling you the model's size, and the final resolution it can generate. It's clear that combining sophisticated parts, like a 3D variational autoencoder, and these advanced encodings, is key to generating higher quality video. So, with all these complex parts working together, how do we actually measure if a model is getting better? This figure shows the evolution of how we test them. Initially, benchmarks like the first V-bench focused on what's called superficial faithfulness, things like frame-to-frame, consistency, and aesthetic quality. Basically, did the video look good? But now, V-bench 2.0 pushes for intrinsic faithfulness, checking for creativity, common sense, and even a basic understanding of physics. The goal is no longer just a pretty picture, but a world that actually makes sense. Okay, so with these tougher benchmarks in mind, let's see how current models are stacking up. This table provides a fantastic overview of different video diffusion models, laying out what each one can do. We see tasks like text-to-video, image-to-video, or even video extension, which is all about making existing clips longer. It also shows key stats like the video's length, its frames per second, and whether it can handle just a single subject or multiple subjects at once. What really stands out is that many of these top models still generate clips under 17 seconds, which really reinforces the core challenge this research is addressing. Right, and looking closer at these numbers, while most clips are short, we are seeing some breakthroughs. For instance, Loong is listed here at 150 seconds, a huge leap. We also see models like Sora and Story Diffusion tackling multiple subjects, which is a big step towards more complex storytelling. This capability is powered by training on enormous datasets, like the Leon 5B or WebVid 10M datasets listed here. It's really a race between major players like OpenAI, Google, and ByteDance to solve these long-form video challenges. So, to wrap things up, this survey really highlights a clear roadmap for the future. While closed-source models from major labs currently set the quality benchmark, the open-source community is rapidly catching up by adopting more sophisticated architectures. The key seems to be combining powerful modules, like the 3D variational autoencoders we discussed, with advanced attention mechanisms, which help the model focus on what's important, and using LLMs to plan stories. The biggest hurdles that remain are the massive computing power needed, and a shortage of good, long-form training data. Thanks for tuning in. I'm Alex, and this has been the AI Research Roundup.